Welcome to the Fire Protection Engineering Podcast, where we ignite conversation about fire protection engineering, safety, and innovation.
I'm Kelly Kidwell, and this is Ben Casey. We're both passionate fire protection engineers here to bring you the latest trends, in-depth insights, and expert advice from across the industry.
From designing fire safety systems to navigating code compliance to business development, we'll explore how engineering can help save lives and protect property.
Whether you're a seasoned pro or new to the world of fire protection, we'll dive into the critical roles engineers play in safeguarding the built environment.
So grab your helmet, check your smoke detectors, and join us as we spark some fascinating discussions about fire protection engineering.
Let's get started on today's episode of the Fire Protection Engineering Podcast.
Welcome, everyone, to another episode of the Fire Protection Engineering Podcast. Today, Kelly and I are going to be talking to Daniel Lang. Dr. Lang is a PE project management professional for Hatch. He's the global director of bus and zero emissions. And we're going to be talking about electric vehicle design schemes, protection scenarios, and maybe go into some of the past events over the last 10 or so years that have driven code requirements and safety and emergency related requirements for the EV industry. So Dan, let us know if you have any other initial thoughts or give us a little bit more about your background.
Yeah, thanks. And thanks for having me on. So as you mentioned, I work for Hatch, which is a global consulting firm, and my group specializes in the transit space. I've been working in that field for close to 19 years now at this point. I've been solely focused on kind of the zero emission fleet aspect of what the transit industry is going through, going back to 2018. So have a lot of experience with helping agencies. If the listeners aren't familiar, there's a lot of local authorities and state municipalities and governments that have set in place goals or requirements to transition entire municipal fleets or transit fleets to zero emissions by date ranges, typically in like the 2035 to 2040 time range. And if you think about some of these major transit operations, could be thousands of heavy duty vehicles that need to be transitioned, as well as, supporting fleets and things like that. So a ton of battery electric vehicles potentially being stored inside maintenance facilities and being charged there, which could create a lot of potential for potential fire hazards and things like that. And we've unfortunately experienced a few thermal events. I've been involved in investigating those. So it's certainly a hot topic in our industry that we're all discussing right now and trying to put our heads together on how to solve it. So happy to be discussing this topic with you guys today.
Yeah, thanks for the quick overview there. I mean, I know that going to a number of conferences in the public transit space in North America, most agency reps, well, knowing that we work in the fire protection industry, but I generally don't see as much interest in the topic until the last few years. And I think that's because a lot of these facilities are being transitioned into electric vehicle facilities, especially the bus garages, the maintenance facilities. I guess to that end, where are you seeing the biggest change in the space, or where there's potentially the most issues? I guess electric vehicles across the board are a thing or a strategy for different parts of the industry, but I guess busing is where I'm seeing the most interest in issues involving fire. So do you have any thoughts on where the growth may be?
Yeah, so I think that's probably for a number of reasons. Why it's transit and buses probably more so than maybe some other fleet segments is because, government entities have more control over those fleets to, force the transition or encourage the transition in the near term here to meet their climate goals and sustainability goals that they're trying to push forward, more so than maybe private fleet operators or other larger organizations. So that's, I think, why we're seeing rapid acceleration of the transition to those technologies there. Why I think more recently you're hearing more about, these thermal events and things like that is, once these goals were set in place, 3, 4, 5 years ago, most agencies started off with a pretty modest pilot program, maybe 5 vehicles, at the most 25. But now, as we get closer to those 2035, 2040 timeframes that I talked about, it's time to start buying in mass and start transitioning in mass. So we're going from very small, and the likelihood of a thermal event is increasing in potential likelihood, right, because of the number of vehicles we're bringing, the total battery energy that's being stored in those facilities. So that's a potential issue. Of course, as those fleets have scaled up, we've seen a few more thermal events. I still want to caution everybody, they're much less likely to occur than even a diesel fire on a vehicle, but when they do occur, they're very difficult to extinguish and manage. So they get a lot of news and press coverage and things like that. The other issue, I think, is, here I'm located in Philadelphia in the Northeast, but in colder climates and up in Canada and things like that, we aren't just charging outdoors. And in early deployments, that typically was the strategy, just charge them out in the yard or things like that. But that's not feasible in colder climates. So we have large number of vehicles potentially being charged indoors, which creates a whole new set of hazards and potential obstacles to overcome with the fire suppression and detection and things like that. So I think that's why we're rapidly discussing this, more and more and more, until now where I think it's kind of the number one topic almost at these zero emission bus conferences and stuff, more so than just maybe a side topic.
Yeah, that's really interesting. So I guess one of my big questions was, have you seen a change? Well, granted, you said things are changing a lot right now. Have you seen a change in how the different jurisdictions might regulate this kind of hazard indoors, with the battery charging or even just storing? I feel like the codes take a little while to catch up. And at least from our side of the profession, we want to have some data and some kind of tried and true systems out there before we start, implementing them or regulating them, putting them into the codes. You must do this. So I guess from the fire suppression and maybe even alarm side, what kind of changes have you seen evolving where you're putting these facilities in?
Yeah, it's a great point, great question. Yeah, we've definitely seen that evolving as well. When we first started doing this, I would say, kind of the local fire marshals and first responders, were aware, and we'd include them in trainings and things like that. But until thermal events started occurring at larger scale and it started to become a bigger issue, they weren't as involved in the design of the infrastructure and being involved now. Typically, in a design iteration and infrastructure, we usually do 30, 60, 90, 100% design iterations where we're putting in the charging infrastructure. Now at like the 60% phase, typically we're having a sit down and a workshop with those first responders to review these designs, get their feedback on what we're doing as far as detection and suppression, and talk about the development of standard operating procedures, what happens in the case of emergency, how will we interface with those first responders to put out fires and drag a vehicle out and all sorts of things like that. So it's definitely becoming a more involved process and a little bit more standardized. But to your point, there aren't any established standards specific to our industry. We're using standards for stationary battery storage for indoor facilities or we're trying to apply other codes and standards where possible, because there really isn't something specifically designed for fleet storage, indoor charging of electric vehicles in the manner that we're doing in the transit space at this point. So we're having to apply best practices. Agencies are sharing knowledge and guidance and trying to use best inferences from those things, starting to do some simulations and to come up with the development of those designs. But that's really where things stand on that front. And then the other thing I would mention is, in addition to the local fire marshals and those sorts of governing bodies, we're also having a lot more involvement from insurance brokers. So that's kind of new to the industry as well. So once one of these thermal events occurs, then they are starting to realize the risk and potential hazards here and coming in with their own sets of requirements. Again, those are inconsistent in how they're being applied from area to area and broker to broker, because again, they don't have codes to rely on either. And so that is injecting a whole nother level of review and approval and diversity in kind of the way that we're mitigating these hazards.
Yeah, it's interesting from our point. Well, I guess from our standpoint, there's not a ton of research out yet. I think there's research going on, hopefully right now. I know that NFPA or maybe SFPE, one of those had commissioned like some research on electric vehicle fires in parking garages. So I think that's probably more applicable to the kind of work that you guys do. So hopefully that research is coming out soon, because like you said, we kind of need guidance. Everyone's just all over the place right now. I feel like the FM global requirements are different from the NFPA 13 requirements, and just nobody knows exactly how to effectively put in suppression systems for these kinds of fires that doesn't completely break the bank, as far as like over engineering it or over designing it.
Yeah, I think, I mean, Dan and I have talked about this a number of times, and I think the battery energy storage system standards and requirements have gotten fairly robust. I mean, whether they've been adopted everywhere, I don't think is the case, but they are out. They have been researched. There is some solid background, but obviously when you try to apply those to a transit facility in a dynamic environment, things change, right? And I think, NFPA 130 and the transit standards haven't necessarily addressed the two combined into a single, document. So there's a lot of, I think, battery energy storage requirements that are being pushed out there. Then there's a lot of separate transit requirements that have always been around. And there's massive fuel needs for the transit industry, right? So there's always been that hazard, but obviously not a lithium ion or other type of requirement.
Well, it's like we've kind of figured out that fuel hazard. Like, it's been around forever. We know how to fight it, and we're still trying to figure things out. Right. The battery energy storage systems are not the same hazard. You have these vehicles that are moving around, might be in a different place. You can't like install a system inside of it. Well, I guess you could, but how are you going to regulate that coming in and out of your facility? I guess if you're like a transit authority with your own buses, you can do that, but not if you're, I don't know, a parking garage, like at an airport or a mall or something like that.
Yeah. I mean, that was actually some of the biggest items. There is localized in-bus suppression systems that you can get, but then you're right, like you'd have to retrofit buses, and you'd have to force the manufacturers to include that, or provide a third party. Another big one that I don't think a lot of people have seen lately, we've seen encased molded intumescent thermoplastics. So it's a composite fire resistant material that you can put in around the different battery cells to stop thermal runaway. So it's essentially a fire break within the battery compartment between cells. Getting that intimate with the hazard is not really something we've seen a lot of, but I know that they're starting to mold those intumescent chemicals into different, materials to protect these types of scenarios. I guess with all that said, and all the different ways we can go with this, I guess, Dan, what have you seen in general, even globally, to address this, just from like just a macro standpoint? Like, are people more focused on like heavy suppression with like water deluge systems, or are you seeing more specialized systems, maybe more focus on like fire curtains or passive brakes? But what are you seeing out there?
Yeah, so, with some of the onboard items that you guys touched on, we've definitely explored those concepts. Fire suppression onboard vehicles has been in place for quite a long time in the transit space with diesel vehicles. Foam suppression systems and stuff have been standard practice for a lot of transit agencies. We've gotten mixed guidance and feedback from fire safety experts on how effective those would be for the types of thermal events that we might experience with battery electric buses. And so I would say I have not seen those deployed in large scale yet for those. One of the issues also that we run into with battery electric buses is they're quite a bit heavier than existing diesel vehicles, and we're pushing the frames and structures of those vehicles almost to the limit to try and get additional range out of them. Because they offer, in most cases, less than half of the range of a diesel bus. And so any additional equipment and protection systems that we're installing on board the vehicle can sometimes cause issues for the bus OEMs, and might, safety should always be a priority, but it's just something to consider as far as additional equipment that we're installing. As far as some of the more advanced tactics that you mentioned on board, as far as separation between battery cells and things like that, I think they're great technologies and concepts that can potentially be applied. But I would say in the transit space, we're typically a bit behind other industries as far as getting new technology evolutions like that. I would say probably the major, car OEMs and things like that, Ford, GM, Tesla, et cetera, would probably be more advanced in their development and R&D on those things. Bus builders, really what they do is they design a frame and they integrate subsystems that are designed by other companies, electric propulsion system by, a major company like Siemens or something like that. And they're not designing all the subsystems. And so they're not really on the cutting edge of a lot of these technology things. So we'll probably be a bit staggered getting those on. Now, as far as what we're seeing in actual application at the agencies, I'd say most agencies are primarily focused on detection and detecting as soon as possible on board the vehicles, more so than suppression on board. So working with the bus OEMs to work with their onboard diagnostic systems to find out what are the precursor faults that'll come out of the battery management system and some of the other devices on the vehicles, so that we can get early detection signs that a thermal event might occur, things like off-gassing and temperature fluctuations, other things that might be occurring on that vehicle. So as soon as possible, we can actually have the telematic systems on those buses send out messages to the O&M staff and maybe even to the fire suppression systems to kick in preemptively before fire even begins to occur. And agencies are finding that that's the fastest and most cheapest, most effective way to get to the bottom of it. As far as suppression, we're seeing high hazard category fire suppression systems being installed. Flow rates upwards of 0.7 GPM and things like that to try and mitigate it. But that's typically determined and dictated through some of these fire simulations and analyses and things like that are starting to become common practice as part of the design phase. Haven't seen many fire curtains applied in transit applications. I have seen some fire walls being set up to kind of segregate the zero emission bus fleet from the rest of the fleet and things like that in places like Europe. But one thing I would note in the transit industry that might be different than other sectors is if you've ever been in a transit garage, especially in a dense urban environment like New York City or something like that, the vehicles are packed in those facilities as tight as they possibly can be. They are mirror to mirror. And so introduction and putting in charging infrastructure and things to support zero emission buses is already cutting into capacity constraints of those facilities. So inserting other equipment and things into those facilities can be really constraining and limiting. And so that also has to be considered and kind of weighed. So again, safety is always first, but there's a lot to be considered as far as trying to pack all these things into these facilities and make them work. So
Interesting.
Yeah, that's a really good point. I feel like, I know I've seen a bus garage, and yeah, they are packed in there. So even if you were to do some kind of automatic suppression for the building, like a sprinkler system or some other kind of like water monitor, yeah, you really do. You have all these obstructions to worry about, especially if the ceiling is not very high relative to the bus height. So it's definitely a challenge.
yeah, and even getting access to first responders. If you have buses 6 deep in a row and then 5 wide in a stack, if for happenstance it's one somewhere in the middle of that grouping that catches fire, it's really difficult to plan for. Of course, I have overhead suppression systems, but it seems like most designers are treating those as a way to keep the fire contained and at bay for as long as possible until first responders can get in there and take more effective action and put more water onto the situation. But it can be really difficult to come up with an emergency operating plan to get access to those vehicles and lay out, emergency paths for vehicles to get in there with the density that we pack the vehicles in these facilities.
Yeah, and even just the construction of the facilities too. I'm thinking like if it's just a metal structure with no fireproofing whatsoever, like on the steel, that could be a really hot fire in a building that is not very resistant to heat. So that's, I guess, building construction type is also another thing to consider in these facilities, maybe requiring spray applied fireproofing where it might not be required otherwise.
So that's a
Yeah, it's
good,
definitely been a big factor. Sorry, Ben. And you know, a lot of these bus garages are very historic in a lot of locations. You might have been converted old armories or things like that. And so certainly were not designed maybe even to be bus garages, much less to store these zero emission vehicles. So extensive upgrades and modifications to the point where it might not even be feasible, and you might just be looking at replacing the facility might be in the cards based off of those upgrades you talked about.
yeah, that's what I was hoping we'd maybe take a wider view, take a step back from the fire protection and just like what kinds of projects, like what is the scope of the projects that you're involved in? Are they, for example, are they generally just a heavy electrical engineering retrofit project generally, or is it more structural modifications? Are you dealing with a lot of new facilities? Like just maybe walk us through what your typical scopes of work are for Hatch and for yourself. And I would assume your competitors as well are sort of set up the same way to do these types of projects.
Yeah. So yeah, I would say when, you know, kind of going back to some of my earlier comments, you know, when these projects started off as pilot studies, I would say they're mostly just, you know, heavy electrical infrastructure upgrades, you know, installing maybe 5 to 25 DC fast chargers in a location. You know, typically those would be ground mounted, you know, dispensers, just like you'd use on, you know, a light duty personal vehicle or something like that. But as we grow out now and we're starting to get into full electrification of the garages, these projects are becoming more extensive. And so, you know, those same space constraints I talked about on the fire suppression side, you know, having all these chargers mounted on the ground and things like that can take up a lot of space in a depot. So things are going vertical, they're going in the air. We're also using, you know, pantograph-based charging in the bus industry. If you're not familiar with it, it's kind of like what you see on a train, where, you know, the pantograph goes up and makes contact with an OCS system. In the bus world, it comes down from the roof of the garage and makes contact with the vehicle and distributes, you know, charging at a rapid rate. And so, you know, that's a lot of weight to be hanging on the roof structure, in addition to all this fire suppression equipment that, you know, now is being added to it. So it kind of evolved from, you know, these pilot studies where we're small to larger electrical build outs of the whole facility. But now that the, you know, the risks and hazards of fire safety are becoming more known, now it's becoming standard practice for the designs to also include the fire suppression considerations. And so now we're typically seeing that. So it's, you know, it's structural, it's you know, the mechanical for the fire suppression systems, also the ventilation and things like that. And then the electrical that's always been a component of it. And then, as I discussed, you know, as we start to do these analyses, oftentimes some of these historic facilities, it's necessitating, you know, the build of a whole new facility, because it just doesn't make sense, not just for the fire suppression, but for all aspects of battery electric. They need to be maintained and operated in very different ways. You have, you know, overhead catwalks and stuff required because there's roof mounted equipment that needs to be maintained. The vehicles are more heavy, as I mentioned, so lifts can't support it. It's really a massive shift in the way that these you know, operators run their fleets, and so it requires potentially completely reconsidering the facilities in which they're stored in as well.
Yeah, that's kind of what I was getting at. I mean, I think very recently there was a bus that was up on a lift that fell over and released the natural gas into the facility. There were a couple fatalities for that one. I was just thinking about how, you know, maintenance is probably very different. That's interesting about the catwalk and having more on the ceiling or more connected through the ceiling space, especially with the powering equipment. So most of it isn't a plug-in sort of recharge device. It lowers from the ceiling. Is that generally how it's being set up?
Yeah, our clients are typically selecting a mixture of those technologies. But again, you know, going back to the example of, you know, one of these densely packed urban bus garages, if you think about the dispensers, you know, there are ways to hang plug-in dispensers from the ceiling as well, but it's very difficult for, you know, what we used to call fuelers are now chargers, to navigate through this bus facility, pull that dispenser down and plug it in, because there's almost not enough space for people to safely pass between these vehicles. And so these pantographs allow for, you know, to more densely pack those buses into the facilities and for us to install more charging infrastructure. It also allows for a little bit more automation and flow of charging operations because typically these are being done throughout the course of the night. Charging can take as long as 6 hours in some cases with electric buses. And so, just bringing all the buses into the garage and having these pantographs and things operate in a more automated fashion offers some advantages. So, typically there are still some plug-in chargers at the depot, but as we scale up, we're seeing more and more deployment of these overhead gantries, starting to see some inductive charging in some scenarios and things like that. And we actually do work outside of transit in the port space, and now we're starting to see automation and robotic charging arms that actually make contact with the vehicle on their own and do things that way. So I think we'll see more of that in the future as fleets scale up as well.
That's cool. Yeah, I'm interested. So on the detection standpoint, are you seeing detection systems going into the buildings themselves, or is that more on the buses? And then if they are in the buildings, are you seeing, is it some kind of gas detection for these EVs, or is it more just like smoke or flame or IR kind of detectors?
Yeah, it's a mixture. So I think the first approach has been more on the bus side to
Okay.
address it there because we're closest to the source. There are gas detection systems that we can put into the battery modules there. The battery management systems are always monitoring temperature and things like that. One of the issues with a lot of the battery electric bus designs is a lot of the batteries sometimes can be mounted on the underside of the vehicle, which causes issues with detection systems, thermal detection or flame detectors and stuff like that, getting first access to being able to see those flames and detect them. So that there's some advantages to doing it that way. And then on the facility side, we are seeing it's mostly, flame and IR type detectors that are being installed in most instances. We have seen some instances of like false alarms, like buses being parked under, heaters in the garage and stuff, setting off the suppression system inaccurately. So there is more of a focus now on the communication systems, between the chargers, the buses, and the fire panels in the facility, so that they're all talking together, verifying data and trying to get that data in as quickly as possible and making sure you get the mitigation started if necessary, but also don't flood a garage. Because if you're talking about these high flow suppression systems, if they do activate incorrectly, it can cause extensive damage. We really can't design facilities to have this occur on somewhat regular of a basis. So it's something else that needs to be considered as well.
Yeah, unless you want like 6-inch floor drains everywhere.
Yeah, and one of the things we're seeing in the transit space as well, due to all these capacity constraints that I just talked about, is we're building up, and we have 3, 4, 5-story bus garages, and so then what do you do with drainage systems and things like that? And these garages are also already becoming exorbitantly expensive, and so adding things like that and just make them less and less feasible. So yeah, a lot needs to be considered there.
Yeah, not to mention if like the environmental regulatory people start coming for your fire water drainage systems and saying, no, oh no, you can't discharge that. You need to capture it on site because understandably, it's extremely toxic, these EV fires, when you fight them with water, all kinds of nasty runoff. So
Yeah, that kind of speaks to, I'm looking at the different like root cause analysis categories for the fires that have happened over the last 10 or so years. And one that jumps out at me that maybe people hadn't realized, like a flood or environmental intrusion into the facility, which, introduces salt water, causing short circuits, that it's indicated as one of the major root causes for fires that have happened either, during a hurricane, during a flood event, et cetera. Interesting. It's like, you're not always thinking about those types of situations turning into a fire scenario. Other ones, obviously, like mechanical damage, puncture of the cells during an accident. There's a lot of testing incidents in EV manufacturing facilities that got out of control. And their biggest, response to that is recommendations of isolating test bays, et cetera. So I guess, it's a planned event, but in some ways it can get completely out of line with this type of energy device. And then production line faults is another interesting one. Like for high density manufacturing without safeguards. I guess a lot of it seems to come up in manufacturing. Do you touch any of that, or is that someone else within Hatch that works on those kind of facilities? Like, so where does your sort of scope or market end and others begin in this space?
Yeah, so we have different groups that specialize in, battery development. Hatch has whole separate groups that are in the kind of mining and mineral space that kind of actually do full life cycle of batteries. So bringing it out of the ground all the way through development and production. We have groups that are focused on the, recycling and handling of batteries and their secondary life. So our team is more focused transit specific implementation and things like that. Now, when it comes to a transit battery, it is common practice in the transit industry during production builds to have quality inspection teams on site at the bus OEM to do testing. A lot of times in the industry, we do, first article inspections on different subsystems and components going to the manufacturer to inspect their quality procedures for how these things are produced. So those are some of the ways that these transit agencies can get ahead of, potentially some of the defects that can work their ways in. But some of the upstream stuff as far as manufacturing at scale and some of the issues that could occur at those facilities are outside of my group's purview. But I would say probably some similar risks and hazards to what we're experiencing once they're moved to our site and we have large quantities of them stored inside the buses and things like that.
Nice. Kelly, any further thoughts on sort of past fire scenarios or anything along those lines? I know we had talked about that major parking garage incident. I think it was in the UK. That sort of scooted under the radar, I think, in general, just because there wasn't an occupied space at the time. I think it was the middle of the night in a parking garage, but due to the vehicles being more plastics than metals these days, the vehicles were melting, molten plastic was running through the drainage, igniting vehicles on other levels. There's those sorts of material issues, I think, as well, that are contributing to the problem. I don't know if any other thoughts on that.
Yeah, from my perspective, we've always looked into, the materials that are put into vehicles and done fire testing and things like that on the vehicles to make sure that, the passenger compartments can remain safe for certain periods of times in the events of fires and things like that. But you're right. I mean, there's definitely, composites and things like that are working their ways into vehicles now to help with weight restrictions and stuff like that can, be contributing to, additional fire hazards and risks and stuff and things like that need to be assessed. So yeah, it's certainly, need to look at these issues holistically. And, kind of going back to one of my previous comments, the thing I would say it's a little bit different from our industries versus, the light duty markets is, a lot of these light duty OEMs are developing, service, specific platforms for EVs. It's a whole different vehicle line and model. The whole structure of the vehicle is designed differently for EVs. Until the quantities of electric buses grow to a larger scale and become kind of the majority of orders placed, it's logical that the bus OEMs are going to use existing structures that were built for diesel vehicles and kind of just retrofit them and install batteries in compartments where engines used to be, as an example. And so until we have kind of purpose-built buses that are designed for to be electric vehicles and be designed with some of the hazards and risks in mind of these thermal events, you could potentially have increased risks associated with maybe some structural components and things like that were maybe not originally designed to be utilized with them. So it's worth taking a look at these vehicles holistically from all the way down to the structure to assess how it contributes to these issues.
Yeah, that's interesting too, because I just wonder, I don't know, kind of the economics from the manufacturer's standpoint, if they even, I'm assuming the EV buses are more expensive than just your conventional diesel bus. So they're probably just trying to make them as cheap as possible without going too much over so that, different transit agencies are incentivized to even consider them. I don't know. Are there tax credits for
Yeah, that's a good point.
cities or regions that buy these types of vehicles?
Yeah, so the way purchasing of buses is typically done is it's usually some split of federal funding and then a local split, and it's been that way even back to the diesel days. It's usually about roughly 80% of the cost of the bus is paid through federal funding. So there's established grant programs and things like that in place, and then the last 20% is usually made up by the agency and local government and stuff like that to pay for the cost of them. The cost of the buses is quite a bit higher than diesels. It's 2 or even 3 times more expensive than a diesel bus a lot of times to procure them. I wouldn't say that necessarily the bus OEMs are making these things as cheaply as possible to help get the costs down. I think they are making strides and putting a lot of effort into developing quality products, and we've certainly seen improvements over time. But there's a challenge. You can think about the scale of a bus manufacturer versus a General Motors or a Ford. They're not producing as many vehicles off the line on a daily basis, and there's considerable overhead costs to be shifting back and forth. And there's a lot of fuel modes that we use in transit, right? We have diesel buses, we have hybrid buses, we have battery electric, we have hydrogen fuel cell buses, we have trolley buses that use overhead lines. And so every time you're switching over your production line to produce a different vehicle with a different configuration, there's costs and things associated with that, which really complicate this and drive up the costs. And then, as we know, there's a lot of market factors going on right now, like the new tariffs coming into place and global economics, and the cost of batteries fluctuates drastically. And so these are all just things that are influencing the cost of it and help distract away from some of the topics that we're talking about here today and keep us focused on improving maybe some of the onboard diagnostic systems and things like that. So it's just we're forging a new path with all these new technologies. These are pretty new. There's a lot to be done to just improve the electric propulsion systems themselves. And so I think it's just there's going to be some growing pains and some development that's going to be needed there. And again, I don't know that the transit industry is best suited to be there's certainly a lot of innovation going on. They're doing that, but it's going to have to also come from some other industries that maybe have some different funding streams, bigger R&D departments and things like that to help bring those things over to transit at a bigger scale.
So do you think it's mostly regulatory driven, like environmental concerns, or is this more of a cost savings initiative for a lot of transit agencies? Like, are they looking to reduce overall costs by reducing fuel costs, or is it more, holistic?
I would say it's more sustainability. I mean, there have been arguments made for, the fact that this should reduce operating costs by transitioning to the zero emission fleets in the future. That's rarely been realized during early goings for a lot of reasons. I mean, the facts are facts. I mean, electric propulsion is superior technology to an internal combustion vehicle, right? It's more efficient. We know from other transit modes like trains and things like that, at some point these technologies will be superior and we will experience better operating costs. But early goings, there's been success stories, but there's also been a lot of failures and high costs and things that have been experienced. So I think primarily the focus is on sustainability and helping to improve air quality and things like that. But yeah, in the long run, the long vision, it should potentially offer some benefits in operating costs and stuff like that. But I don't think that's the primary focus. And transit is not a money-making business, right? It's not really designed to make money, but by its nature, it's supposed to create economic development and spur regions and things like that. So it's never really been the focus is on the economics. It's more on the greater societal and community benefits that we're trying to bring.
Yeah, good point.
Yeah, really interesting and off topic from our normal fire protection stuff, but I don't know. I think it's interesting.
Yeah, I guess so. If you could have anything going forward here that would improve your ability to generate the results you want for these facilities, what would be sort of the big ticket items, whether it's, a faster contracting process, more solid regulatory framework, I don't know, more of a focus on the funding source involving, transit-oriented development and more clarity on like that, and so where the projects will be. Like, what is, if you had, the perfect wish list for what could come up in the future, what would you push for?
Yeah, I think, we've talked about it a lot, but I think the regulatory and code aspect of this is really the next major step that needs to be accomplished. Just having us all working off the same book here and working towards the same thing would really be beneficial, because we've experienced this with other technology booms in the transit industry, where new technology is imposed through regulatory requirements. We start moving towards it, and there's 3 or 4 technology iterations that occur during the time frame that we're supposed to transition to that new technology, where technology is ruled obsolete and needs to be replaced, and it's exorbitantly expensive and it's very disruptive to operations. At the end of the day, we're really supposed to be focused on delivering service and moving people from point A to point B. And so, to the extent that we can get those things codified and solidified in the near future, I think that would really be of the most benefit. And not just for battery electric buses having a code, or it doesn't need to just be for battery electric buses, storing electric vehicles in large scale indoors and charging them indoors, right? Having some sort of a code for that. It's not just about that, though. It's mixed use facilities, right? Because I think for most operators, not just transit, like Amazon and other private fleet operators, I think there's going to be some mixture of fleet technologies that are going to be deployed in the coming years. Mixture of continuing with internal combustion engines. There's a lot of deployment of hydrogen vehicles in certain sectors like forklifts and things like that. But when you start applying multiple codes now to the same facility, it gets even more complicated, and we're experiencing that a lot. And our agencies want to have the ability to pivot and adjust their plans over these 15 or 20-year time horizons. And so if we could have kind of a cross-section, set of codes that could be applied to the facility, design them to maybe the most conservative circumstances, so these agencies don't feel too wedded or married to any particular technology and have a little bit more flexibility to pivot in the future, I think that would really be beneficial as well.
And are you mostly focused on fire as the biggest hazard for these facilities? I like to always expand kind of fire protection engineering, just because NFPA does touch a lot of different hazard sources, hazard types. I mean, they cover electrical safety, right? National Electrical Code is an NFPA document. So just from the standpoint of, hurricane, civil unrest, I mean, anything that could possibly come up, flood, is fire really up there for you in these types of facilities, or are you generally more focused on protecting the facility against other hazards that might be a more structural related design feature?
It depends on the geographic region and the specific circumstances, but I'd say it's moving up the pecking order to getting towards the top of our list of concerns. Electrical safety is certainly a major concern. Most of these bus garages, these people have never worked with high voltage systems before these come in. Transit agencies are experienced with it because of rail and other modes but usually these garages are different operating divisions, and so we're bringing new technology. The staff are completely unfamiliar with lockout, tagout, and all sorts of electrical hazards. So that has been here from the start, even when those small pilot studies before we were as aware of the risks of the fire. So that's still a component of it. But there's other risks that are involved in certain regions. For example, we've done projects on the West Coast in Vancouver and elsewhere where earthquakes are a major concern, and so there's a lot of structural requirements associated with that. So it's really got even with the fire suppression, all these sorts of things, we do fortunately have a structured framework within transit that the FTA has rolled out, which is doing a detailed hazard and risk assessment as part of the design process, and we go through a formal safety certification of all major capital projects. And so the nice thing about that is we already have some established procedures. They're not tailored specifically to fire safety, but it's in the early process in the preliminary engineering, identifying what all the risks and hazards are that could potentially exist in this facility, and then through those design iterations, coming up with mitigating design standards or maybe operating procedures or other things to mitigate them. And so we're well equipped to address these things. We just got to have the design solutions and some of the codes and standards kind of caught up, and then I think they'll quickly integrate themselves in. But that's kind of what we're working towards.
So from a standard standpoint, I always think it's interesting. We can kind of have tunnel vision when we're specifically in our industry thinking of fire protection, but certain industries, it matters what the industry association and the folks who work in it day to day think would make the most sense with the most experience in the actual operation of things. So for example, we do fire protection for the nuclear industry, the nuclear regulatory agencies, their guidelines, even though a lot of them reference NFPA standards, et cetera, there's a lot of basic information you have to know in order to protect those facilities. So when I think about transit, I think about the American Public Transit or Transportation Association. I never know what the full words are in the acronyms, but APTA's guidelines, for example, they're very specific, even though they may reference documents for more detailed requirements. They're very specific to transit, right? And they know what the operators have needed. They know more about kind of the overall environment of how those facilities are put together and run. So I guess from that perspective, are there any standards or guides or just maybe case studies you've seen that you could direct folks in the fire protection industry to look at or start with that you think, need to be known or read as a baseline before getting into this?
Yeah, there are several. There's been some case studies of some of the fires that have occurred in Europe. There was a major bus fire at a depot in Germany, for example, and there's been some case studies on that, some lessons learned that have been developed out of it. But here locally in the US, the FTA has a guidebook on deploying battery electric buses, it's called. And it does provide some guidance on how to step through this process. It's not prescriptive. It doesn't tell you what flow rate you should have on your fire suppression systems or what detection you should install, but it does give you guidance on what sort of methodology should be followed to thoroughly, characterize your risks and hazards and go through it, kind of that safety certification process that I mentioned. It has some preliminary guidance in there for early adopters, some very conservative assumptions that can be taken if you're not to the stage where you're doing detailed fire simulations and modeling or major overhauls of your facilities. Like, for example, just keep your buses 15 feet apart. There's some very conservative assumptions that are placed in there that agencies can use in kind of the interim until they have time to go through some of the more thorough steps. So it's a good starting point, a good baseline. And I think as some of these codes and standards become developed, like you said, a more industry specific document like that could exist and just reference specific parts of the subcode and things like that, but to infuse some of the operational knowledge that's more specific to our industry. And I'm hopeful that other industries that are doing large scale adoption of electric vehicles would have similar documents, and we can all kind of adapt things specific to our industry.
Kelly, any final thoughts or final question here?
No, I didn't have anything else. Thank you, Daniel, for joining us. I learned a lot this past hour, and I think it'll be really interesting and applicable information, especially for our listeners who are fire protection engineers who might have to start designing these facilities here soon.
Yeah, transit is an interesting industry. I sold my car like 15 years ago after I started going to APTA events a lot and hadn't really gone back since. I don't know if you've gone that crazy as me into transit at a certain point, but.
Yeah, no, I'm certainly a heavy user of transit. I believe in the service that's offered. So yeah, I've been working in this space, like I said, for 19 years. So I believe in the service and the type of stuff that we do. And it's only becoming more exciting to me because it kind of started to align with some of these things with electric vehicles and stuff like that. So there's a lot of exciting things going on here. And I'm excited that we get to be kind of on the forefront of some of these new things. It's a challenge, but it's also rewarding when we come up with solutions and stuff like that. And I know the industry will respond and come up with some really unique and innovative ways to tackle this problem.
Yeah, and transit and transportation is the forefront of the emissions issues, and it's a big one out there for global warming impacts and other environmental considerations. So it's an interesting space to work in, and we appreciate you getting involved.
Yep. And thank you both so much for having me on. I really appreciate it, and looking forward to maybe some feedback from the industry. We're really counting on your industry to help us move this thing forward. I know there'll be some great results from all this.
All right. Thank you. Thanks, guys.
Thank you.
Thanks.
And that's a wrap on today's episode of the Fire Protection Engineering Podcast.
We hope you found today's discussion as illuminating as a well-designed sprinkler system. That makes no sense. Remember, fire protection engineering is all about making spaces safer for everyone.
If you enjoyed today's episode, be sure to subscribe, rate, and leave a review. And don't forget to share the podcast with anyone you think could benefit from it.
Got questions or topics you'd like us to cover? Drop us a line on social media or through our website. We love hearing from our listeners.
Thanks for tuning in, and remember, safety is no accident. Until next time, stay safe and keep engineering for a safer world.
See you next time on the Fire Protection Engineering Podcast.